has a length of 0.8 meters and a diameter of 5 times 10 to the power of minus 4 meters. The IV characteristics of the wire is shown. So the current against voltage graph of the wire is shown in the current against voltage characteristic. So what is the resistivity of the metal from which the wire is made? We are told its diameter, we are told its length, we are told the IV characteristic. What can we find from the IV characteristic? We can find the resistance of the wire. Why is the resistance needed? We are looking for resistivity. So resistance is equal to resistivity length over area. So here we are looking for resistivity. So resistivity is resistance times area over length. So resistance, how do you find it? Resistance is equal to voltage over current. So here we can take a voltage of 5 and a current of 2.5. So the resistance will be then 2. So the resistance is 2. So we're going to say 2 times cross-sectional area will then have to be pi r squared. The diameter is 5 times 10 to the power of minus 4. So the radius will be 2.5. Remember in brackets, the radius 2.5 times 10 to the power of minus 4 in brackets squared over the length. The length in this case is 0.8. The length is 0.8. So therefore we're going to say 2 times pi 2 times pi times 2.5 in brackets times 10 times 10 times 10 to the power of times 10 to the power of, let's say, well, that's minus 4. Close bracket to the power of 2. Okay. Divided by 0.8. That will give us an answer which is 4.9087. So times 10 to the power of minus 7. So the answer is there, like that. Okay, the next question says 10 cells of EMF 1.5 volts are connected together as shown. What is the combined EMF between terminals X and Y? So this cell is facing to the left, 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 and one facing to the right. So those ones facing to the left have a combined, there are 9 of them, so they have a combined EMF of 13.5. So minus the one facing to the left, then that would be 12. 13.5 minus 1.5, which is 12. Then the next question says, a cell of EMF E and internal resistance R is connected to a variable resistor as shown. The resistance of the variable resistor is gradually increased from R to 3R. Which graph shows the variation of potential difference across the internal resistance with the potential difference across the variable resistor? So we want a graph of potential difference across the internal resistance and the potential difference across the variable resistor. Now you must understand that the potential difference across the variable resistor plus the potential difference across the internal resistance, they are the only two resistors in the circuit. So the potential difference across both of them should add up to the EMF, whatever the case. So if we check, let's say D here, if we are at this point, we have one which is EMF E and one here. So this adds up to 2E. So they are not adding up to E, which they should. If we come here, check this one. Okay, 0.5 is fine, add up to E. But if I come here and if I come here, this will probably not add up to E as we would want. Okay, but we'll come back there, because let's say that it's approximately, because here's the thing now, it will probably add up to E, because this would be maybe 0.75 E, this would be 0.25 E, they will add up to E. But the problem that we have is that the resistance of the variable resistor is actually being increased, meaning that it is not possible. The resistance of the internal resistance is always R, whereas the resistance of the variable resistor starts from R, meaning that at first the variable resistor, when they rated the resistance of R, small letter r, and the internal resistance with the resistance of small letter r, their resistances were equal, and then so they were sharing the E equally. That's why it was 0.5 E for V, small letter v, and 0.5 E for capital letter V, the voltage over the variable resistor. But the voltage on the variable resistor must only increase. It cannot be decreasing. It cannot decrease because the resistance on the variable resistor was being said to be increasing from small letter r to 3R, 3 small letter r, which means that the share of the voltage obtained by the variable resistor must only increase. This C is showing it decreasing to 0.25 whilst of the EMF, while the internal resistance is now getting 0.75, which is not correct and cannot happen. Then this one, even though we will not consider much, this is 0.25 plus 0.25, that doesn't add up to E. So this one is the perfect one now, because it is showing that the EMF for the voltage across the internal resistance has decreased to 0.25, but this one across the variable resistor has increased to 0.75, which means that the sum is still equal to E, but this across the variable resistor has increased as it is expected. So the answer is A because of that. Okay, then number